right? So selection sort algorithm. So I explain the steps, right? Let's see with an example how to do selection sort. Right here, yeah, there's a slight change. If you can check, right? So there are two ways. I mean, I have explained it like step through the array starting from the second item. Also, we can start with the first item itself. I can මෙතන මේ පළවෙනි item එක මුලින්ම තෝරගත්තා. ඊට පස්සේ දෙවෙනි item එකේ ඉඳන් තියෙන minimum එක හොයන්නත් පුළුවන්. එහෙම නැත්නම් පොදුවේ මේ පළවෙනි item එකේ ඒ item එකත් එක්කම minimum එක හොයන්න. So if the minimum is the item that we have selected, so first we selected one item, right? If the minimum is that item, so then we don't have to do anything. So otherwise, we may have to do swapping. ඒක මේ පොඩි වෙනසයි තියෙන්නේ ඒ දෙවිදිහටම අපිට කරන්න පුළුවන් මේ. ඒ දෙවිදිහටම ඒ කොයි විදිහට කරත් එන ස්ටෙප්ස් ගානේ වෙනසක් වෙන්නේ නැහැ. Number of steps would be different. I mean, so there are slight differences. I mean, we can neglect, right? Okay. So let's see the example. Right, like we start with the first item, and then we try to find the minimum. First minimum would be 57 itself, and then we try to find the minimum. 82, no. 33, yes, it is smaller than 57. So minimum would be 33. But here, remember, so we are keeping the index. The index where the minimum is, not what is minimum. If we know where minimum is, so then easily we can get the value. If we know the index of the minimum, using that index, we can directly get the value. No problem. So we keep the minimum index. If we keep the value, minimum value only without the index, so then we don't know where the minimum is. When we have to do the swapping. Swap කරන්න ඕනේ වෙන වෙලාවදී අපිට මොකක්ද minimum value එක කියලා දැනගෙන වැඩක් නෑ. අපි දැනගන්න ඕනේ minimum එක කොහෙද තියෙන්නේ. අන්න ඒ කොහෙද තියෙන්නේ. අන්න ඒ value එකත් එක තමයි swap කරන්නේ. minimum එක කොහෙද තියෙන්නේ කියන එක මේ තියෙන්නේ index එකේ. So we have to keep the index, right? Right, so here the index 2, the value would be 33, and then go on, and the 12, the next value, it is smaller than the current minimum. So new minimum would be, the index would be 3. The value would be 12. So then we do the comparison, 99 no, 64 no, 2 yes. Now we have the new minimum, index 6, the value is 2. And then 24 no, 45 no, 70 no. Right? So then finally the minimum would be 6. The minimum value would be index 6. Right? So in that case, we swap with the first one, or the 0th index. After swapping, 2 is here, and then 57 would be here. 57 would be moved to this one. Abhi swap karai. So this is after the first step. So now we start with the second item. We don't have to touch this one. Forget about that, and then start with index 1. The index 1, the minimum would be, first minimum would be 82 value, then minimum index would be 1. Then 33 years, it has to be the new minimum. So the minimum would be index 2. And then 12 years, it has to be the new minimum. So minimum index would be 3. The value would be 12. Then 99 no, 64 no, 57 no, 24 no, 45 no, 70 no. Right, so finally the minimum index would be 3. So we swap these two values, 82 and 12. So the 12 comes here and then 82 goes here. Right now, first two values are okay. We start with the third value, index 2. Index 2. So the minimum value would be index 2 now at the beginning. So then we check the values. 82, no. 99, no. 64, no. 57, no. 24, yes. It is smaller than the current minimum. So the new minimum would be index 7. New minimum would be in index 7. The value is 24. So then we compare the new values with the new minimum, right? 45, no. 70, no. So the minimum would be in index 7. So we swap these two values. Now 24 comes here, 33 goes here. Right, likewise, we do that until the whole array is sorted. Until the whole array is gray, like this. First three values here. ඔක්කොම array එකම නිකන් අලු පාට වෙනකල්ම අපි මේ විදිහට මේ process එක continue කරනවා. So that is selection sort. So we select the minimum and we move it to the front. Suppose if you are doing this sorting in descending order, then instead of finding the minimum, you can find the max. Max එක හොයන්න පුළුවන්. Minimum එක වෙනකොට max එක හොයන්න. Right, so this is the program. Again, we have a swapping method, right? Don't worry about that. Right? Again, we have two for loops, outer loop and inner loop. We have three variables and then one for minimum in that case. Right? So if we try to write that program, let's write. So we can, okay, I'm going to copy this program. This method. And then I'm going to change it. Selection sort. Sorting the array in an ascending order. Using bubble sort in the previous case. Using the selection sort. Right? Okay. So in this case, both loops goes forward. Right? Only difference is the starting point of the second loop. Right? Outer loop goes forward. Starting with 0, I, n else. I plus. Inner loop goes forward, starting with the position set by the outer loop. Starts with I plus 1. I is this one, and then I plus 1. And again, it goes up to n else. So this is not, there's no difference. And j, sorry. So j, right, okay. And then so the outer loop, the position set by the outer loop to find the minimum value. In order to do that, we need a minimum. Int min variable. At the beginning, set the minimum to the first item. Minimum is assigned with I. That would be the minimum. Yeah, yes. Right, so then compare each item with the minimum. First, not first item, first index here. First index. Compare each item with the minimum. Item, right? So we compare each item j with minimum. We have to check whether other items are smaller than minimum. Minimum එකට වඩා පොඩිද කියලා බලන්න. If they are equal, no worries, right? So we don't do swapping here. We don't do swapping here. If we find any value which is smaller than minimum value, then new minimum value would be that value, that j value. J index, the index. New minimum index would be j. Right? So somehow, after that loop, right? After this loop, after finding the minimum, we do the swapping. Swap. So we have swap program anyway. We have to give the values here. You have to give the index actually. You have to swap I and you have to swap me. I and me. In this case, out means I. Huh? Out means I in my program. In means j. The program that I have given, the value out means I. Sorry, I. So in this case, if you want, you can do something additional. If I is not equal to, ඒ කියන්නේ මේ minimum එක මේ I කියන එකට සමානයි නම් අපිට මේ වැඩේ කරන්න ඕනේ නැහැ. swap කරන්න ඕනේ නැහැ නැත්නම් ඒත් swap වෙනවනේ. ඒ හින්දා මේ මෙහෙම දාන්න ඕන නම් පුළුවන්. This is additional. This is something additional. No. Actually, we don't need necessary. So we don't need, because we are doing that with I, right? So then yeah, no, it is fine. It is fine. Sorry. You can keep it. So if you want, you can do that, right? Even without this, it would work. It would work, but unnecessary swapping would be there. එහෙනම් මෙහෙම තිබ්බත් කමක් නැහැ මේක නැති වුණත් අවුලක් නැහැ. Right? Okay. So we do the swap. Swap the minimum value with the selected. Right? That's all. So we have two for loops. We have one for loop here, another for loop. This is the selection. So again, in this case, integer variables out, in. Right? That's the only difference. So this is out. So if you want, you can use those variables. No worries. And then in this case, J in. Okay. This is the program. So any questions? Any questions? Anything? මොනවාරි ප්‍රශ්න තියෙනවා නම් අහන්න. If no questions, we can move on. We can go to the next section actually. Insertion sort. So before going to insertion sort, if you analyze this program, you can identify the number of swaps are less because it is not in the second for loop. It is outside the second for loop. මේ loop එක යන හැම වෙලාවෙම swap කරන්නේ නැහැ. loop එක ගිහිල්ලා ඉවර වෙලා තමයි swap කරන්නේ. හැබැයි ඒක so however the comparisons, we do comparisons. Number of comparisons would be same as the bubble sort because it is inside this for. loop එක යන ගමන් swap කරන එකයි loop එක ගිහිල්ලා ඉවර වෙලා swap කරන එකයි වෙනසක් තියෙනවා අනිවාර්යයෙන්. Right? Okay. Then insertion sort. In most cases, the insertion sort is the best of the elementary sorts discussed up to now. In insertion sort, so we improve the previous selection sort further. Right? It is about twice as fast as bubble sort and somewhat faster than the selection sort in normal situations. this is important in normal situations. In some in special cases, sometimes, for example, like selection sort would be faster than insertion sort. In some cases, right? Generally, insertion sort is twice as fast as bubble sort and somewhat faster than the selection sort. It is also too complex, although it is slightly more involved than the bubble and selection sort. Sorry, it's also not too complex, not too complex, but little bit complicated than the previous ones. කලින් දෙකට චුට්ටක් මේකේ ටිකක් මේ වැඩ කෑලි වැඩි වෙන්න පුළුවන්. හැබැයි මේක එච්චරම complex නැහැ. It's often used as final stage of more sophisticated sorts such as quicksort. So we are going to learn quicksort in the next semester. So the insertion sort is the final step of quicksort. Quicksort එකේ අන්තිම step එක තමයි insertion sort. It is used in quicksort is the best in most of the cases the best sorting algorithm that we can use. So that's why it is called quicksort. It is faster. It's way faster than most of these sorting algorithms, right? So insertion sort is a part of quicksort. But today we are going to discuss insertion sort. Next semester we are going to discuss quicksort. Right? Insertion sort iterates consuming one input element each repetition and drawing a sorted output list. At each iteration, insertion sort removes one element from the input data, finds the location it belongs with the sorted list, and inserts it there. It repeats until no input element remains. Right. So let's see what this means. Right. So let's go with an example. Okay. Right. So in insertion sort, insertion sort, we are going to divide the array into two, right? So we have sorted part, right? So this is already sorted. This part is not sorted. Not sorted. Right? So I'm talking about one point in the middle of this algorithm. Algorithm එක දැන් කරගෙන යද්දී අතරමැද අවස්ථාවක් ගැන මම මේ සලක කියන්නේ. This is an intermediate step in this algorithm. So our array is divided into sorted part and unsorted. So in non-sorted part, so we remove one element. we remove two from the array, right? Suppose the value here is 23, right? So this value is removed, taken out. And then, sorry, 23, yeah, right. Then what we do is we compare this value with our sorted part items. Can sorted part එකේ තියෙනවනේ elements ඒවත් එක මේක compare කරනවා. Starting with the next item, adjacent item of this sorted part. මෙතන compare කරනවා. So what we are going to do here is we are going to find the proper place for this item in this sorted part. මේ 23 කියන එක න කොතෙන්ටද ගැලපෙන්නේ කියලා බලනවා මේ sorted part එකේ. So sorted මේ කොටස තියෙනවානේ. ඒ sorted කොටසේ 23 කියන එක න දානවනම් කොතෙන්ටද දාන්නේ කියලා තමයි බලන්නේ. So we are trying to find where to insert 23 in the sorted part. So if this is sorted, so values would be in an order here, right? So the largest value would be here, the smallest value would be here, right? Then you can start with largest value, one at a time. Then at one point we find, okay, so 23 should go here in between these two. For example, suppose this value is 19. This value would be 30. Right. Then 23 should go in between these two. Okay. So in that case, what we have to do is, so we have to shift these items. And then we can shift this item here. And then the 30 goes here, and likewise other values goes to the next. And then we have now the vacant. Now we have the vacant place. We can put 23 there. Now this part is now sorted. We added one more to the sorted. Sorted part incremented by 1. Then we move out this value. Suppose that value is 99. Right? Okay, let's put some values here. 42, 51, 62. Right? When we edit the values together. This is 3, 10. So now, so we have 99 here, right? 99. So we take that value out and we compare with these values. Not matching, like I mean, so we have to find a value smaller than this. Sorry, larger than this. Value larger than this. No larger than. Right now, we don't have to check other values. මේ පළවෙනි value එකෙන් check කරාම මේකට වඩා පොඩි නම් ප්‍රශ්නයක් නැහැ. අපිට ඉතින් එහෙම check කරන්න ඕනේ නැහැ. We don't have to check further. So that means there is no proper place for 99 in this sorted part. So that means 99 can be added here itself. ආපහු ඒක තිබ්බ තැනටම දාන්න 99. We don't have to do anything. So now this part is sorted. So this part is sorted. This part is not sorted. So likewise, all the arrays becoming sorted, we can do this. Right. So then I told you I started with an intermediate question. So when at the beginning, what we do is we can start from the second item. We can start from the second item. Right. We can remove the second item and compare it with the first. Right. එතකොට දැන් මේ මම කියවනේ අර කලින් මම පටන් ගත්තේ මැද තැන කියලා. එක පැත්තක් sorted අනිත් පැත්ත unsorted කියලා. ඒතර මුලින්ම පටන් ගනිද්දී අපිට මේක මෙන්න මේක sorted කියලා ගන්න. එකක් විතරක් ගත්තොත් මේක sorted කියලා. So we start with the second item, index 1, and we remove that value and we check whether there's a place for this value there. අපිට මේ value එක මේකේ තියෙන්නේ 10යි මේක 33 කියලා. So we compare this value. We remove that value, right? And then we compare it. So 10 is smaller than 33. Then 10 has to be in front of 33. So in that case, we can shift until we find a smaller value than this. You can make it a value එකක් එනකල් අපි මෙහෙම search කර යනවා. මේකෙන් නම් search කරන්න තියෙන එකයිනේ. බිඳුවට යනකල් හරි පොඩි value එකක් හම්බ වෙනකල් හරි search කරනවා. Search කරලා එහෙම හම්බුනොත් we shift. So after finding smaller value or 0, until that place we check and then we shift. 33 goes here and then there are no values to be shifted. So this vacant place is assigned with 10. Right? See? Now this part is sorted. These two are sorted, right? we can take the next value out and check where it belongs in this array. Right. So likewise, we are trying to expand this sorted part. Sorted part is expand. That's what we do. So is it clear? Is it clear? Sorted. Sorted part, it was make an unsorted. It may sorted part එක expand කරගෙන එන එක තමයි කරන්නේ. Insertion sort iterates consuming one input element each repetition and drawing a sorted output list. See, drawing a sorted output list. Sorted part එක draw කරගෙන එනවා. At each iteration, insertion sort removes one element from the input data, finds the location it belongs within the sorted list, and inserts it there. It repeats until no input elements remain. Right, so this is actually sorted or partially sorted. This array, this part is sorted. Then again, this is an intermediate step. Marked player, selected player. This player is removed, right? Removed. And so we have now an empty space. So we have to find the proper place for this player to be inserted in the partially sorted area. මෙයාට හරියන තැන අපි හොයාගන්නවා. එයාට හරියන්නේ මෙන්න මේ දෙන්න අතරනේ. So now we remove this person and then we shift. We shift and then insert that removed person here. So we have the queue. We have the queue. So imagine that we have the queue and then we remove one person and then we find where that person belongs in that sorted part. And then we shift other players and put that player in that proper place. So we insert a selected item in its proper place, in an appropriate place. කියන්නේ මේක අපි insert කරනවා එයාට අදාළ තැනට, එයාට හිමි තැනට insert. So that's why we call it insertion sort. Right, in the next step, so this player would be marked and then that player can be put here, right? Somewhere here. So likewise, we continue that until all the players are moved into their proper places. Okay, so when it comes to the algorithm, so we can explain it like this. So any questions before explaining the algorithm? Any questions? Okay, right. So let's go to the insertion sort. Insertion sort start at the second item, index 1, and the item at 1 is removed from the array. Right. Insertion sort start at the second item, index 1, and it is removed. Then it iterates the array backwards, starting from the previous item. One index left to the selected item. Compare each previous item with the current selected item. So we start with index 1. Right. 2. Right. So we remove index 1 and compare that with starting with the index left, the index before the selected item. This is selected. Selected index. එකට කලින් එකේ ඉඳන් අපි compare කර කර යනවා. Then it iterates the array backwards, goes backwards. Compare each previous item with the current selected item. Previous items are compared with the current selected items or removed items. If each previous item is bigger than selected item, they are shifted. If each previous item is bigger, if we find bigger items, we compare. If we find bigger items, they are shifted. Local items are they are shifted. They are shifted. One index left to fill the gap created by the removed. Sorry. They are shifted one index right. It has to be right. Shift කරන්නේ මේ පැත්ත. Has to be right. The small item is found the selected item is inserted into the one position left to that smaller item. Where the, actually it belongs to the sorted item. One position, right to, this has to be like right, this has to be right. If no small items are found until the array ends, then the selected item is inserted into the 0th index position. Then the item with one index left to the previously selected item is selected and continue the same process. Again, this has to be right to the previous selected. Likewise, select items one by one iteratively and insert them in their positions. Right? Okay, so let's try to understand it with this example. Right? So we have two variables, in and out, two variables. So the in, both are in the at the same position, index 1 at the beginning, and then that selected item is moved, removed, right? 80, the value is 82. We compare that with the previous 57. If we find a bigger value, if you find a bigger value than this one, then we shift. Again, අපි දැන් 82 කියන එක තමයි remove කරේ. ඒ 82කට වඩා ලොකු values හම්බුනොත් ඊට පිටිපස්සේ. එහෙම වුණොත් අපි shift කරනවා ඒක එකකින්. In this case, we don't have to shift. If we find bigger values than 82, then we shift those values. But here we found 57, which is smaller. So we don't do anything, we don't shift. And what we do is we move this 82 back, right? කියන්නේ ඒකේ අපිට මොකුත් කරන්න දෙයක් නැහැ 82 ආපහු තිබ්බ දැනටම දැන්. Then we go to the next one. Now these first two values are sorted. These two are sorted now. Partially sorted. Huh? So we have to add some other values into that. Partially sorted. Now we remove the third value, or the index 2 value, 33. So now we compare 33 with the previous values, starting with 82. So 82 is bigger than 33. So if you found bigger values, so then we shift that value right. 82 is shifted right to this one. And then we compare 33 with the next value, 57. 57 is bigger, so we shift that value, right? So now 50, you see, 33, we don't have any other value to be compared, so then 33 is put into this value, this vacant place. So if you see one thing, right, like here, when the values are shifted, 82 is shifted, there are two variables, in and out. So in is moved to where it is. For example, here, see. Now in is here. Then in the next case, in is here. So then 33 is moved to in. So then we choose the next value. In and out are both are there. We remove that value, 12, and we compare that value with the previous values, 82. It's a bigger value. It is shifted. And then in is now here. In is now here, like we are 82. And then it is shifted. And then 12 is compared with 57. Yeah, it is bigger shifted. Then it is compared with 33. It is a larger shifted. So then finally 12 is moved to in. Now this part is shorter. So we select this one and we remove it. So complete the steps until out reaches at the end of the array. Out කියන එක මේ පැත්තට යනකම් මේ වැඩේ කරනවා. Every time, so if you see from the beginning, out is moving from index 1 to the right. And every time in is moving left from out. Out එකෙන් පටන් ගන්න in එක පිටිපස්සට යනවා. Like this, see? Is it clear what we are doing here? If it's clear, so then we can go to the program.